Now let's put everything together. First thing, if I give you a problem, the first thing I want you to do is there a common factor? Can you factor something out of all the terms? If there's not a common factor, is it a binomial or is it a trinomial? Are they perfect squares? So if it's a binomial, are they difference of squares? If it's a trinomial, is the first term a perfect square and the last term a perfect square? If it's not perfect, if it's not one of those, then is there a number in front of x squared? Then use your British method of factoring that. If there's no number in front of x squared, use the diamond method of factoring that. Then after you do all that, look at your answers and start over and say, hey, can I do that again? So I start off again with my answer. Is there a common factor in my answer? And I keep on going until you say no to everything. So let's take a look here at this application problem. It says a graphic designer drew a logo with the dimensions shown. Write a polynomial that represents the shaded region. And when I say shaded region, I'm thinking blue region. So I'm going to take the area of the big rectangle, which is going to be 32 times 16. I'm going to subtract the area of the little triangle, which is x, or 2x times x. Well, 32 times 16, we'll use our calculator there. 32 times 16 is 512. Minus 2x times x, well, that's 2x squared, isn't it? Now, let's go through our terms. Is there a common factor? Yes, there is. I can factor out a 2, can't I? So I factor out a 2. So if I take 512 and I divide 512 by 2, I get 256 minus x squared. Okay, I factored out my common factor. Now I look inside the parentheses and I notice, oh, there's 2 terms. Binomial. Is there, nothing goes into both of them. Is this a perfect square? Yes, it is, because 16 times 16 is 256. X squared is a perfect square. So I can factor that parenthesis. So I'm going to say 2 times 16 minus x times 16 plus x. And you know what I just realized? All of this that we just did was example 6. Let me pull that down there for you. There we go. All we had to do was write the expression for the shaded region for example 5. Then in example 6, we're going to factor it. Then I look at, can I factor this again? Well, 16 is a perfect square, but x is not a perfect square. So that I can't use my perfect squares. And that's the only time I can factor a binomial is if they're difference of squares. If it's not a difference of squares, I know I can't factor it. So then we're done. So that was 2 times 16 minus x times 16 plus x.